work. You see me heavy work. You see me do.
We've done one data set. Here's another one that's pretty famous from about the 1950s by Mr. Box, who is a very famous statistician. And what they did is they took a bunch of fabric, like jeans, and they were laying them on sander belts to see how long it took to break through the jeans. And that's one way they can test how tough that material is. We have a special chemical filler that's used and a surface treatment, and we have different filler mixtures. And we're wondering, out of all these combinations, does it matter which one you use? And I told you this was a famous data set because it exemplifies why interactions can be so important. So to read this doc file, I've saved it as a TXT, told it the path to go get it on my desktop, done double slashes, and I also need to skip the first 7 lines. Did it work? We can find out by looking at our data set. Excellent. Now, durability is what we want to predict based on the proportion, the surface treatment, and the filler. So the first thing I want to do is go ahead and take a look at the effect of these variables on durability. It looks like as the proportion increases, tough to see. How about surface treatment? Okay, it looks like increasing surface treatment drops the durability. So this is obviously a bad surface treatment. Fill looks about the same as surface treatment. So I'm going to make a linear model predicting the durability based on all 3 of these. And I'm not going to put multiplying because I don't have any reason to think that there's an interaction yet. So my residuals, there's a little bit of wiggle there. That looks good for the normality plot. This one definitely shows curvature. Cook's distance, you don't even see those red dashed lines, so it doesn't look like we have any outliers. But could we model something better with that curvature right there? Well, let's see what each of the individual type closure fit dollar sign. Well, let's look at the residuals based on each of the variables. And let's do it in a 1-by-1 plot. Don't really see a pattern there. Not much of a pattern there. And not much of a pattern there. Wow, that's stunk. So overall, this could be called a good model. I wouldn't feel bad if any of my method students said, I think that these 3 just need to be predictors in the model. And you would get an R-squared of 0.75, which is pretty good, especially since this is real data, and an S of 25. But I told you at the beginning that this was a famous data set because the client suggested there really should be an interaction. What type of filler you use and how much of that filler you use changes how durable the fabric is. So can we notice that with our picture? Well, notice in these pictures that we have 2 values for surface, 2 values for fill, and 3 values for the proportion. So this is somewhere between being categorical and numerical. You could call this low, medium, and high. They actually are equally spaced, which is valuable to use in our analysis. But I'm going to try coloring them based on the other variables. So let's look at this graph of the proportion, and we're going to color it based on surface. Now, when I say that, R is going to look at the number values of surface and pick the color that corresponds to those number values. So we're going to get some weird colors out, black and red. That doesn't really count as weird colors. But notice black is up here, red is down there. Is the slope of the red dots different than the slope of the black dots? Yeah, maybe. Looks like it. Now, if we color it based on fill, wow, those red and black dots seem to be all mixed together. Would I say the slope of the red dots is different than the black dots? If it is, I really don't see it as clearly. Let's try looking at surf. Okay, well, I warned you that it would look at the values of prop, which are all values below 1, and so it colored them with white dots, which really doesn't do me any good. So I'm going to say pick different numbers. If I times it by 10, now this is going to be different values. It looks like red and light blue. There's no way you can see that. Okay, 10 was apparently too high. If we go by 5, now I've got black and red and green, which are all good colors. So actually, I think that's dark blue. But here's the line for the dark blue or black. There's the line for red, and there's the line for green. Does it look like it has different slopes? Maybe. Surface. Red is down here and black is there. That one I would say I can clearly see there's an interaction here. The black dots tend to give us a flat line, but the red dots give us a more steep line. What do we see if we look from the fill direction? I I see black and red and green kind of all mixed together. I'm not sure that I really see an interaction there. This one I can see the same interaction we saw before. Red seems to have a steep decreasing line. Black seems to have a fairly level flat line. So looking at those different plots, some of them show an interaction, some of them don't. How am I going to know which ones should be an interaction? Well, I'm going to do the lazy approach. That is going to give me all the interactions. And I didn't see much of a problem with the residuals before, but I'm still going to check them. And actually we saw more of a curve here, and that curve seems to have evened out a good deal. I'm liking that. We do find some data points that are a little more unusual when you're looking at the interaction, but not bad. They're not outside those dashed lines. And this residual and the others, they still look fine because we couldn't really see a pattern before anyway. So let's clear my plot so that I can size my window and see if we like the kinds of p-values we're getting. That would be a no. Now in the next chapter, multicollinearity, we're going to talk about the big key thing. We've said it twice already. Delete stuff one at a time. And there's our ugliest thing. It has a big p-value and it's ugly, so that's going to be the one I'm going to kill. So how do I get rid of the three-way interaction without getting rid of the two-way interactions? Well, I need a prop surf and a prop fill and a surf fill. This has all the two-way interactions, but not that big three-way. And look, there's a bunch that now you can start to see. What's happened is we've cleared away the junk, which means patterns that you couldn't really see before are starting to pop up. Now who's complicated with a big p-value? This guy right here, prop times surf. This term doesn't need to be multiplied. Now, we'll get prop by having this variable, and we'll get surf from this one. So I actually don't need to put in any of those. And so I can make it look a little nicer. And we still see surf. Now, here we've got a little bit of a dilemma. And this was the same dilemma that we faced in categorical interactions. What happens when surf is important times fill, but surf is not important times itself? Same answer as before. You get to choose. And you could find statisticians who would argue this value of 10.83 when your error is 22. You can call it 0, you can call it 10.83. Neither one is necessarily better because the p-value says you can't prove any of those values. Either 10 or 0 would be better. So I'm going to have to make a decision. I am going to decide to leave it in, which means here is my final model. Which variable is easy to talk about? Not proportion because it has an interaction, not fill because it has an interaction, and not surf because it has an interaction. So none of these three turn out to be quite as simple as we thought it might be at the beginning. So let's start by drawing the proportions picture, which means prop needs to get a sequence. I deleted all my plots. You know what? I'm too lazy to draw a plot. Mouse over. The range goes from 0.25 to 0.75. So 0.25 to 0.75. Length just needs to be big enough to give me lots of dots so that it looks like a line. Now, for surface, I'm going to pick something low, and it either goes 1 or 2. So we'll start with 1. And then fill goes with either 1 or 2. So let's start with 1. And now I need my prediction equation. Although I'm getting sloppy. These are values I'm going to use to make my predictions. So let's give them hats. And then Dura hat is like that. And let's draw our line. We'll start with red because I think I'm going to have it. It's probably more of a rut. Oh, Dura is not found. Oh, because I didn't say data equals fabric. Let's try that. There we have our line. That is the line when surface level is 1 and the fill hat is 1. Now, we're talking about proportion. What interacts with it? Only fill. So fill is the one that's actually important to change to 2. So let's plot when the filler equals 2, and look how those lines are different. What about surface? Well, surface doesn't interact with proportion, so the only thing it would do if I change surface from 1 to 2 is it would shift these. So I'm actually going to do that and draw it so that you can see what that effect is. And I've said L2I2 because I want it to give me some dashed lines. So let's do surface area of 2. There's red. and there's green. So the effect hasn't changed, meaning if you look at the slopes, the red slope is the same and the green slope is the same. The only thing changing the surface area did was it shifted this red down and that green down. It's true that it shifted it more down, but that's an overall effect. What we really care about is, as proportion increases, what happens to the durability? Well, for the red line, as the proportion increases, the durability increases. For the green line, as the proportion increases, durability is almost the same. It goes up only a little bit. So I really have two choices here. If I like this graph or that graph, both are explaining the effect of proportions and how it changes versus red and green. We could even zoom in on just the interesting parts by coloring that data white and then zooming in on the y-axis between 2 and 300. If you noticed before, it was going from 100 to 250, and now I've zoomed in from 200 to 300 so that when I draw my lines, they fill in the picture. And actually, maybe 300 is too much. I think I'd go to 280. And now I've zoomed in on exactly the effective proportion based on each of those filler levels. And I think that's the one I want, except I want to put the legend to the left. Good. And rerun it all. Let's do the same thing for the surface treatment. So then when we talk about the effect of the surface treatment, we have the same three plots. Here's where we just picked a level of the proportion. Here we have drawn all the levels of the proportion. Each of the different lines has the same slope, so it's not like it's a different story, but we can draw different types of lines to represent that. It's a style choice. Or you can zoom in just on the effect of surface for durability based on the different types of fillers. And that was, I paused the video for 20 minutes and had to copy and paste and get stuff right. But to talk about the effect of filler, I don't get all those choices because filler does interact with proportion and with surface treatment. So it has to have 6 lines. But how you show those 6 lines does have some variety according to what you want your style to be. And we could go through the code, but I'll leave it up there. You can go through it on your own if you want. Here's an option where each line is basically its own unique thing. Here's an option where the different levels of proportion are different colors, and then the different line styles are the different surfaces. Or we could split it. Let's just do when surface equals 1, here's a plot, and when surface equals 2, here's another plot. So out of all these options, what do I want my style to be? Here's the 3 graphs for proportion. I'll pick the middle one to give me some nice variety. Here's my 3 graphs for surface treatment. I'll pick that last one because it looks nice and clean. And then out of all these, well, let's see, that one has 2 graphs. Let's not do that. We'll go with this guy. So now to discuss the effect of proportion, I'm going to say as it goes up, durability goes up. And for the filler 1, which is red, the durability goes up faster, whereas filler 2, not so fast. And you can even see that as these lines converge to some point, they converge right here when we're talking about surface area 1, or they converge back here for surface area 2. But I don't necessarily need to discuss surface area because that's not interacting with proportion. I'll talk about surface treatment down here. So if I don't need surface area, do I really need to draw all the different levels of surface area? Not really. I actually kind of wish I had picked this plot because it would be a lot more simple. The client's goal is to have very durable fabric. So now I can say for high proportion, I'll pick the red line. For lower proportions, I'll pick the green line. So that depends on whether we're talking about filler 1 or filler 2. This one matches more my particular style. So I'm going to say increasing surface treatment decreases durability. Obviously, if you're putting more fabric on the sander, it's going to break apart more. But filler 2, it's even more dramatic. So if we have high surface treatment, I'm going to say we should stick with filler 1. And if we had low surface treatment, I would recommend filler 2. And that shows that I've actually thought about what it is that they're trying to explain and what this interaction here means. So I've got to kind of try to break this up. It looks to me like it'd be easier to talk about these 3, and then we'll talk about those 3. So for these 3, increasing filler drops durability, more for the higher proportions. These 3, increasing the filler either increases durability or drops durability. And then I made a note because you can't help but notice that when the filler is 2, these proportions all converge to the same level of durability. You may also notice because this graph shows everything so well, it's not hard to recommend how to get the highest durability. It's right here. Filler 1, high proportion, and surface area 1. And keep in mind, what you're really describing here, it's not just a 3D picture collapsed onto 2D. This is actually a 4-dimensional thing that we've sliced up and discussed. 4-dimensional objects are extremely difficult to talk about, but breaking it up in a picture like this, client can look at it and say, oh, now I can see and understand. And if you can explain this type of thing, you should really feel proud of yourself. So after this, I think we're ready to try the homework. Let's see how we do.